In this video, we're going to talk about the concept of an expected value. And for a probability distribution, the expected value, or the mean of the probability distribution, is the long-term average. What that means is I take the probability experiment and I run it over and over and over and over again, and I record my results. The average of those outcomes is my mean, or my expected value. So it's not what I expect to happen in a single trial, it's what I expect to happen on average after many trials. To find the expected value, we take each value in the table, multiply it by its probability, and then add the results. In other words, our expected value is the sum of our data values times their corresponding probabilities. And you'll remember we saw this symbol when we talked about the mean as well. That math symbol means sum, or to add up all the values. So we're going to multiply x times p of x, and then add up all those values. So let's go ahead and do an example. This one says a lottery offers one $1,000 prize, one $500 prize, and 5 $100 prizes. 1,000 tickets are sold at $3 each. Find the expectation if a person buys one ticket. So the directions say find the expectation. That's another way of asking for the expected value or the mean. In order to do that, I have to build a probability distribution. So I'm going to look at the profit for the player, and then I need the probability for that profit. And there's 4 possible outcomes. I'm told they can win the $1,000 prize, the $500 prize, the $100 prize, or they just pay the $3 and don't win anything. So I need 4 rows in my table. And then I need to start thinking. So if I paid $3 for my ticket and I won $1,000, my net profit is that $1,000 minus the $3 I paid to pay. So that's actually going to be $997 that I made. For my $500 prize, I paid $3. I get $500 back. I really only won $497. And the same for the $100 prize. If I paid $3 and got back $100, I really only made $97. If I paid for a ticket and didn't win anything, I lost $3. And now I need to figure out how likely is it for each one of those outcomes. So they told me that there were 1,000 lottery tickets. So I know that all of these fractions are going to be out of 1,000. And then I look at how many there are. And I was told 1 $1,000 prize, 1 $500 prize, and 5 $100 prizes. That's 7 prizes out of 1,000 tickets. So that's going to leave me with 993 tickets left. If I have 7 tickets that are winning, 993 are losing. Now that I have my probability distribution built, I know that to find my expected value, I need to do my data value times its probability, and then I need to add the results for each row in my table. So to do that, I'm going to add an extra column to my table. And that column is going to represent x times p of x. So that first one, 1 times 997 is 997. Same for the next one. 1 times 497 is 497. And then on a calculator, I have 5 times 97, which is 485. And then 993 times 3 is 2979, and it's negative because it was negative 3. So next thing I'm going to do, I'm going to add down that column. And since the denominators are the same, it's just the numerators that I'm adding. So I have 997 plus 497 plus 485 minus 2979. And I get negative 1000. And that equals negative 1. So what that means is that if I were to buy lottery ticket after lottery ticket after lottery ticket repeatedly, on average, I would expect that my net winning is a loss of $1. Meaning that this game favors the game runner, does not favor the player. In the long run, I'm going to lose money playing this lottery. Let's go ahead and try another one. Next one says, if a person rolls doubles, when she tosses 2 dice, she wins $5. For the game to be fair, how much should she pay to play the game? So we're going to do that same process. I need to set up a table. I'm going to let x be the money 1, because she hasn't lost any yet, because I don't know how much she should pay. And then I need p of x. And it sounds like there's only 2 outcomes in terms of how much she won. She either wins $5 if she rolls doubles, or she wins nothing if she rolls not doubles. And to help fill out those probability columns, I'm going to scroll back to slides from our previous video, because we looked at what happens when we roll 2 dice. So scrolling back up, if I look for the doubles, that's going to be this diagonal here. That diagonal there is 1 and 1, 2 and 2, 3 and 3, 4 and 4. Those are all my doubles. And there's 1, 2, 3, 4, 5, 6 outcomes that I can get from rolling doubles out of 36. So in this table, 6 of the 36 outcomes will result in her winning $5, which means the other 30 must be where she wins nothing. Because remember that this column has to add up to 1. In order to figure out how much she's going to win on average, we're going to calculate our expected value. And we know that our expected value is the sum of x times p of x. So we add that extra column here for that multiplication. So 5 times 6 is 30, so that's going to be 30 out of 36. 0 times 30 is 0, so that's 0 out of 36. If I add down, that's 30 out of 36. So this equals, I'm going to do it on my calculator, 30 divided by 36. is 0.833333333. In order for the game to be fair, we would want the game to not favor the player or the game runner. In that case, if on average on the long run, she's winning about 83 cents, she should only pay 83 cents to play. And in that way, the game would be fair in that the long-term outcome for the player balances out what she's paying to the game runner. All right, if you have any questions on how to do that, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.